All right, so we might get started. Welcome everyone to the launch of our first ever impact report. I'm Ellie Court, CEO of Soars for Life, and I'm really delighted to be hosting today's special event. Soars for Life exists to support Australian farmers to regenerate the soil and the landscape, and you can read a lot more about how we go about doing that on our website. And today we're very excited to be hosting the amazing Dan Kittredge to discuss the fast evolving area of soil health and human health. First, a quick few notes. We're recording this event for our podcast and also for releases of video. And as we have quite a number of people on the line, if you could please stay on mute. We do have some people from our team roving around who will mute anyone who unintentionally comes off mute, but that'll just make sure that we have good sound quality for the podcast. You'll also have an opportunity to ask questions of Dan later on. So please do start thinking of questions now. And if you have a question for him, please pop that in the chat and we'll try to get as many of them as we can during the session. In the meantime, it's always nice to see who's on the line. So please, if you could introduce yourself in the chat and let us know where you're dialing in from. Also, you can change your name that appears next to your face in the video. You can do that by clicking the little 3 dots in the top right corner of your video and clicking on rename, just so we know who you are. But yeah, if you could introduce yourself in the chat and let us know where you're dialing in from, that'd be great. Finally, if you're able, please leave your video on so we can see all your lovely faces and pretend that we are physically in the same place. I'll be trying my best to finish up on time, so please do just forgive me in advance if I jump in at any moment to move things along. Okay. So that's it for the housekeeping. We'll get to the main course in a moment. But before we do, part of the reason for this event is to celebrate the launch of Soars for Life's 10-year impact report. And I really feel humbled to be leading an organisation that's achieved so much in a decade. Much of it, I must admit, is well before my time. And this story is documented in our impact report, which you'll all receive in your inboxes after this event. Before I talk about the report, just a few brief words about Soils for Life. The name might give us away, but we are excited about soil. Soil is so much more than dirt. It's incredibly richly alive. And a teaspoon of healthy soil can hold 10 billion living creatures. And they are wild and wonderful and incredibly tiny. From the microscopic amoeba you can see on the screen, just 0.002 of a millimeter in length, to the nematode, fungi, the beautiful potworm, dipluran, and my favorite, the globular springtail, which is a relatively gigantic 3 millimeters. And this is just a close-up of that beautiful potworm with soil particles visibly passing through its translucent body. Incidentally, this photo was taken on a farm we work with by British macro photographer Frank Ashwood. I think it was a farm in Tasmania. But soil's not just interesting. It's the foundation of life on the planet. This quote is from our founder, Michael Jeffrey, who sadly passed away in 2020. And soil is literally beneath our feet every minute of our lives, but most of us know so little about the critical role it plays in our survival. Healthy soil provides the foundation for all of the planet's biodiversity. It filters and produces clean water. It can absorb and slow floodwaters, keep the landscape hydrated during drought, less flammable during bushfires, and able to bounce back faster after the fires come through. And soils hold more carbon than all the world's forests and atmosphere combined. And of course, soil is the basis of food production, something we'll be talking about more today. No wonder that Michael Jeffrey identified it as the solution to our greatest challenges, and more than half of our soils are managed by farmers. And this is why a little over 10 years ago, Michael Jeffrey founded Soils for Life with the mission to support Australian farmers to regenerate our precious soils. And that story of our first decade is documented in our impact report, which I'm very proud to launch today. There's so much in this report, but I'd just like to bring your attention to a few things that I've loved discovering in the process of compiling it. This is just a little peek at the report itself. So we have reached a lot of people with more than 200,000 views of our case studies. And farmers are telling us that they work. More than 3/4 of farmers said reading our case studies helped them adopt regenerative approaches to farming. The case study farmers have been boosted by the process as well and given new confidence both in their practices on the farm, but also to step up and become leaders and mentors to others. Last year, we received an email from a South Australian farmer, which is just one of the best things I've read. Changing's hard, there are ups and downs, but listening to our podcast connected this guy with a community of farmers all giving it a go and gave him the motivation and the confidence to recommit and to continue. Last year, we brought together more than 40 of our case study farmers, along with NRM organisations, policymakers, researchers and others to celebrate this journey. And I know many of the people on the line today were at this event. And now I'm very glad to share it with all of you through our impact report. I want to give an enormous shout out to all the farmers we work with, of which these are just 4 examples. The stories we've shared have been a source of hope and inspiration to so many people and given many farmers the confidence to try farming differently. But it's not an easy thing to put yourself out there in a sector that doesn't always adore the tall poppy. So I want to applaud all of the farmers who've been involved for your bravery, and thank you for all you've done and continue to do. And just to close off, in very simple terms, I think the last decade of Soils for Life's been about raising awareness of the incredible importance of soil, the critical role of farmers in regenerating soils and landscapes. And now increasing numbers of farmers are becoming curious about regenerative agriculture. And I believe the work for the next 10 years will be helping them shift from curiosity to confidence. And the pillars of our strategy are to do this through case studies, peer communities, building farmers' ability to monitor soil and ecological health, and then maintaining the relationships that we need to inform government and research and industry based on our on-ground experiences. And as part of that, I can see some really exciting new areas for exploration. Different sectors, beginning to collaborate more with First Nations communities, better linking soil health and human health, which of course we'll be talking about today, and underlying it all, strengthening the all-important bonds of trust that enable communities, including farming communities, to function in the face of the huge challenges that we're facing. And this is us, the team. And I must also thank our amazing board, a few of whom I think are online today, and also our generous donors and supporters, without whom none of this would be possible. So that's all I want to say about our report. And you'll all be receiving a copy of this, as I said, in your inboxes after the event. So onto the main course at last. And we really are very privileged to have Dan Kittredge, the Executive Director of the US-based Bionutrient Food Association and the Bionutrient Institute, here today. Dan is an organic farmer based in Massachusetts in the US, where it must be said it's 8 p.m. Thank you again, Dan, for staying up for us. In 2010, Dan founded the Bionutrient Food Association with the quite simple vision of increasing quality in the food supply. Since then, he and his global team of scientists, technicians, engineers, organisers and others have been leading the charge to better understand nutrient density in foods, how it can be improved, and ways to reward farmer soil stewards for food quality. So Dan, thank you so much for joining us.
Thanks for having me. I'm sorry my video is not up today. Yeah.
Yeah, I should note that Dan's got slightly unstable video, so unfortunately we won't see his face, but he is very much here with us. So I want to jump straight into the questions for you, Dan. And to start, only a tiny fraction of the population here in Australia, as in most countries, are farmers or directly connected to farming. But every human being on the planet has to eat, and we all care about the nutritional value of the food we're eating. Most of the conventional advice about nutrition is focused on the types of food we eat. Things like, are we getting our daily intake of fruit and veg? Are we eating a variety of foods? Are we avoiding highly processed foods? But I think my interpretation, at least, of your work is that it shows that there's much more to the story than that. Can you just talk a bit about what's missing from that story?
Yeah, well, I mean, how it's produced or how it's processed. I mean, you can grow high quality wheat or, a lot of things and then process them to make them not good food. But what we've been focusing on is just the logistics of what is quality and not. So, I mean, many years of research and variation is massive, and most of us are not doing a good job. And it connects to soil health and soil life brilliantly. Um, we've been working on meters and market drivers and step-by-step science. So where do you want me to start? What's your
I think one thing that struck me was some of the work you've done around nutrient variability, and that seemed to be the starting point for a lot of the work that you've done. So maybe you could talk a little bit about some of those studies you've done on nutrient variability in quote unquote the same foods and what those found.
Yeah, well, I mean, we started the organization in 2010, and we've been working with growers starting in the northeast part of the US and, broader from there for years. But it sure looks like nutrient variation connects with soil health and farm viability and human health and pest and disease resistance. So we started in 2016 a project. I mean, you want to pull up some of the slides? Can you show people? I think
Sure.
it's slide 5 or 6 where we show the samples from 2020. We've been working on this for years, and I think we have a little more than 10,000 samples of crop and 8,000 samples of soil and management data. Next slide, I think. Yeah, that's 2020 data. So you can see the crops on the right, the number of crops, the number of samples. On the top left, you see the green is farmers, not just sending in samples and triplicate with their soil in multiple depths, but management data also. Not global, but something. You can see in the bottom left the things we looked at in the crops, and the bottom, or in the middle, in the soil. But the variation we found was massive. And the questions we had were, one, do nutrients vary dramatically in food? Two, if they do, what connects to that? And three, if it's true, it's significant, can you build a meter to test it? So, I mean, let's see the next slide. So we have this data right now. Next 4 slides will be on carrots. We have this data for multiple crops, more than 20 crops. roots, leaves, fruits, and grains. This is just carrots, a couple elements, but on the left you see sulfur in carrots. Um, the red, orange, yellow, light green, dark green is 20, 40, 60, 80 out of 100. And the peak of the curve you see there is in the bottom of the 20 to 40 percentile. So the variation is like it's a bell curve. We can see a lot is possible, but most are not doing a lot. And that, 8.41 to 32.19 or 3.19, it's a 4x variation. So you can see a 4x variation in sulfur in carrots. And most carrots are below the 50th percentile. To the right, you see phosphorus, 11 and 93. It's an 8x variation. You can see that, again, with phosphorus, different element, the peak of the curve is at the 25th, 30th percentile. Something much better is possible, but most of what's available is not that. Next slide.
So is it right to interpret, just before we jump onto the next slide, Dan, is it
Yeah.
right to interpret these charts as saying that of the samples of carrots, and how many carrots did you actually bring in? How many samples of carrots?
800 maybe?
800 samples of carrots from across the US, from all different geographic regions,
And
all
Europe.
different soil types, different production systems, organic, biodynamic, local, all different varieties as well. Is that right?
Yes, exactly.
And that you found, at least according to these two slides, 4 times more sulfur in the best carrots compared to the worst carrots, and 8 times more phosphorus in the best carrots
Yes.
compared to the worst carrots.
And the peak of the curve in the vast majority of the sample set is below the 50th percentile.
Yeah. Yeah.
So almost all carrots are low compared to what they could be.
Yeah. Yeah.
And we have this for more than 20 crops. Yeah. Antioxidants on the left, that connects to reversing chronic disease, basically flavor, aroma, pest and disease resistance. And the peak of the curve is in the 20th percentile. It's a 40x variation from 4.92 to 195. 40x. And you see, what's that? 5 on the high end. So some people are doing a good job. And then to the right, you have polyphenols, where the peak of the curve is in the 10th percentile. These are the compounds that actually reverse chronic disease. This is just one crop.
And you've now done these studies for across a number of different crops. All of these studies looking at this variability of nutrients across the samples.
Show this range from 4 to 40x. Yeah.
And when you're looking at that nutrient variability, you've shown us a couple, but what's the range of things you're looking at? Like, we normally hear about things like macronutrients, protein and carbohydrate, and sometimes about vitamins and micronutrients, but can you just describe a little bit about the range of different things that you're looking at in these studies?
This was what we started in 2017, when we had not much money. So we looked at a few elements and a couple compounds. And, since 2021, we've done more work, but we haven't gotten there yet. So we've just attempted to verify the nature of the scale of variation in the food supply. People talk about, in 1950, food was better and now food is worse. And our data points align with what's mostly on the shelf. Almost what's on the shelf, most of it is quite poor compared to what it could be.
And sorry, go on.
Well, I mean, what we're showing is most food is much less than it could be. That was part of our initial question, is like, does variation exist and how big is it? And we'll go forward to the next couple slides to connect to causal factors. And then is it possible to build a meter to test it?
Yeah.
And
Yeah. So we know that
we've
this
been doing since.
variability, it's not linked to any of the things we might have thought it was linked to, right? Like you looked into whether this links to organic farms or
Show the next two slides. Let's show the
Yep.
next two slides. Yeah. So on the left, we have BQI score in carrot, which means it's an average of 6 elements and 2 compounds. And this is by variety. So you've got Napoli and Bolero and Nantes and Mokum. And what we're seeing is you can take a seed of carrot and cause it to have low levels of nutrients or high levels of nutrients. It's not what we're seeing here is that no one variety is better or worse. It has not to do with variety.
Mm.
And the next slide on the right is by climate region. This is just US, USDA climate regions and Northeast and East, North Central and Southeast and Central. We're not seeing a connection by soil type or climate zone. You can do a bad job or a good job, regardless of where you are. Variation is massive, and most are not doing a good job. Next slide. Point of purchase, farm, store, garden, farmer's market. What we found is it does not, point of purchase does not connect with quality. Some people have gardens or are selling in the farmer's market, aren't doing a good job. Almost no one is actually doing a good job compared to what's possible. On the right, by practice, certified organic, cover crops, no-till, till, right? Not major difference between no-till and till. Organic, not certified. Reference and none are basically store-bought. Regenerative, biodynamic, local. We're not seeing a direct connection between label or individual practice and quality. Most people are not doing a good job. What we basically found was that the only thing that connected was soil life. The level of life in the soil is what connected to nutrient variation. So,
And
yeah,
how do you actually measure the level of life in the soil? What are you measuring for there?
that was just what we did from 2017 to 2021. We just did respiration, amount of out breath of microbes when you dry the soil up and add water.
Hmm.
Really rudimentary, but nothing else connected. Variety did not connect. Point of purchase did not connect. Certification label or individual practice did not connect. What connected was actually if you have life in your soil, the more life, the more nutrients. That's what we found.
Hmm. It's amazing. And tell me, how do you actually measure, like what's the actual tools to measure the difference between nutrient levels in different foods?
That's a whole long conversation. Which lab and which meter and I mean, how much money you got. And this was just what we did to say, do nutrients vary dramatically? If they do, what do they connect to? We think soil health, not individual soil type or variety. And then next slide is, can you build a meter to test that? And so we built that in 2017, but we released it in 2021. We sold a couple hundred of them around the world. And yes, you can have a meter that's at a consumer price point you can flash a light with and get a reading off of food.
Hmm.
Not that we know what quality is, but we can actually test individual things with confidence. So
Um,
we've been working forward since there on individual crops and beef and yeah.
and so where's this up to? We did have a couple of questions submitted before the event about where the meter's up to, when it's expected to be coming able to be purchased, what price point, and I'm also interested in what changes do you think it might bring once this is widely available?
So the first point to understand is that you can't calibrate a meter to nutrient density until you defined it. Before Celsius defined a scale which said frozen water is 0 and boiling water is 100, Celsius couldn't build a thermometer calibrated to his scale. And until we've defined nutrient density in any crop, we can't actually build a meter to test it. So
Hmm.
we've built meters to show that you can test individual nutrients in individual crops, so it's possible. But The real work is to define nutrient density first, and then we support anybody in building a meter that can test it. But
And
that's
is it
$1 million a crop on the first crop, and then hopefully less than that on subsequent crops. But it's a project, and you know, we can't stand up and speak with confidence about science until we've done the science.
hmm.
And it's
And is
got to
it
be open. It's got to be open source.
And is it right to say that defining nutrient density in this context means um, defining what are quote unquote good, better, best levels of of various nutrients in different foods?
Exactly, which is the next 3 or 4 slides.
Yeah.
So we said in 2021, it looks like nutrients vary dramatically. It looks like that nutrient variation connects to soil health. It looks like you can build meters. So let's define nutrient density in one crop. And we said, what's the crop with the biggest ecological and economic footprint of anything else? And it's beef. And our hypothesis was that what the cows ate connected to the quality of their meat. So next slide is, the specifics of what we've looked at. Hundreds of compounds in the meat, hundreds of different microbes in the manure, all aspects of the forage and soil and management and human health trials. And we've completed that data collection now, and we're about to hand it off to the scientists to give us a red, yellow, green, or something more nuanced between now and the end of the year. And we propose that as soon as next year, we may be able to have meters that can test beef. And if we can test beef, it probably is true that chicken and pork and eggs and milk actually are similar. Which, I mean, next slide. I mean, you can see the global footprint, which is mostly North American, but keep going. With the omega-6, omega-3, it looks like what cows eat sure connects to that. And we can test whether somebody is selling something as grass-fed because it was ate grass when it was 6 months old or grass-fed when it was finished. And so imagine we have the ability with a handheld instrument, starting with the companies, but then going to consumers in short order to verify the caliber of the meat that's being provided to the global supply chain. I mean, I think Australian farmers are a big piece of the grass-fed beef that, market that we have in the US. Um, so yeah, next slide is basically showing that the diversity of the sward is directly connected to the quality of the meat. And
Can you
that's
just
preliminary data.
can I just interrupt, Dan, and ask for those who aren't familiar with the omega-6 omega-3 ratio, can you just describe, what that is and why it's important?
I wish I could explain it better, but it seems to connect massively to inflammation, um, which is causal to all chronic disease.
Hmm.
And we have very high levels of inflammation in our Western quote unquote diet. Um, and if you can balance that out, you can begin to systemically reverse chronic disease across the population. And so, not just beef and milk, but how about pork and chicken and turkey? And I mean, if you're feeding grain to animals, here's a very uncomfortable fact. If you're feeding grain to animals, like chickens and turkeys and pigs, which has very high omega-6, omega-3 ratios, even if they're on pasture, the vast majority of their foodstuffs is imbalanced, and the nature of what you eat is not healthy. I mean, humility all around. Um, I grew up on a farm 40 years ago where we had chicken tractors and pastured pork, but we mostly fed them grain. And actually, based on what I understand now, I can tell you that's not right. That's not what pigs and chickens were eating 100 years ago, and that's not um, healthy for the people that are eating their eggs or meat. So,
Yeah.
yeah,
And so your first study that we talked about earlier was looking across a range of different types of foods at just the variability of some of the nutrients in those
Yep,
slides. Those were the first charts we were looking at. This study is more of a deep dive into beef. And I think you've said the results, the full results from this study will be coming towards the end of the year.
exactly. Yes.
And what's next after beef? Where will you be going next?
Wheat is the next thing we'll study, but if we can take our insights from beef and apply it to chicken and pork and eggs and milk and support growers in, better economic viability, we shouldn't just move on too fast.
Hmm, hmm.
But grains are next.
Yeah. And so what about the farmers? What does this all mean for them? There's clearly an opportunity. You showed those slides that show that, very few of the samples you received were getting anywhere near to the highest possible levels of nutrients. So there's clearly an opportunity, but maybe also some challenges. So what are your thoughts on the implications of this work for farmers? I think you might be on mute, Dan.
Yeah, I keep trying to unmute. I can't. Um, the implications are that uh, about 15% of the sample is above the 50th percentile of what's possible. So a very small percentage of us are doing anything resembling good. I grew up in the 80s and 90s. I went to college in the 90s. If you got a less than a 60 on your final exam grade, you were a failure. And I can safely say that about 15% of the sample is above the 60th percentile. 15% are passing with a D or a C or a B or an A. 85% of the farmers are producing crops below the 60th percentile. So the bar is not high. The bar is not high. Almost everyone is doing a bad job. Let's be humble and let's understand that it seems to correlate with soil life. And you can identify as cover cropping or permaculture or no-till or whatever, but it seems like it's the actual function of life in your soil that really matters. And yeah, it's the bar is not high. And
Um,
we're gonna keep working forward to define it and support consumers and accessing quality and grassroots and honorable and empowerment. But I mean, the connections between soil health and ecological function and human health and consciousness, they're very exciting. So
I was interested to see that's that chart on the links between practices and nutrient density, land management practices and nutrient density, and what that really shows is that there's no link between
it's
practices.
not a practice per se, it's about the level of life in the soil.
Yeah.
If you're a proper steward of your land and you're supporting the level of life in your soil, that's what matters.
Mm, mm.
That's what matters is the level of life, not the practice or the certification. Yeah.
Uh, and I think that's something that we talk about a lot, is that there's no practice-based recipes in this work. You can't simply take a set of practices, apply it to your farm, and think that that's necessarily going to give you the best outcome for soil health. And I think this is actually taking that, your work is taking that one step further, and it's saying there's no recipe to produce life in the soil, which is the only thing that you've found correlates with nutrient density of the food.
I think the recipe is sensitive, loving, caring.
Mm.
I think the recipe is presence on your land as a steward. And being, the more you can engage the subtle levels of communication, the better. But it's not about thou shalt not till or thou shalt cover crop in such a way. It's about engaging the level of life as sensitively as you can.
Mm. Mm. Absolutely. You talked a minute ago about the handheld tool, and I think the idea there is that that is meant to be a device for consumers to take into, well, for businesses and then also for consumers to take into the supermarket and literally point at a carrot or a tomato or whatever it may be, and get a reading of the nutrient density of that food across various different compounds. Um, First of all, I'm just interested in briefly, how does that work?
It's called spectroscopy. It's how we know what stars are made up of, and planets and star systems and things. It's Hubble and James Webb Telescope. We don't send probes out to test various planets. We take a picture of the light coming off of them, and every element or compound in chemistry is a vibration in physics. So if we can read the light properly off a thing, we can see what it's made up of.
Mm, mm. That's amazing. And how do you expect this, like, what do you expect the impacts of this device getting into people's hands to be? Like, what are you hoping the impact will be?
If people can look at three carrots on this, three different bags of carrots from different brands on the shelf, or three different brands of beef or chicken or pork, they can know this is 80 out of 100, this is 20, this is 15. And they can look at the price point and say this is $8 a pound or $6 a pound or $5.50 a pound, and they can make choices accordingly. But for those who, want access to that knowledge, we provide that, and we trust that they will make decisions accordingly to support themselves and their children.
Mm,
So
yeah.
it's not a pressure, it's not an obligation. It's a data point.
Mm,
You
mm,
have knowledge about the nature of what's on the shelf and you can purchase, and what the price points are and everything else. And if simultaneously the cost of production is lower for the farmer because the animal or plant is healthier, they don't need a premium to be more profitable. But I mean, I see in the next number of years, those who are doing a better job will be likely offered premiums of significant nature, I think, but only if we have this stick, carrot and stick, how to do it, but also the ability to test it. We have to have that ability to test. I mean, my parents wrote some of the first organic standards in the US in the 1980s, and I watched the organic movement get perverted by money. And foundational to my entire strategy has been, how do you create a structure that can be, you know, um, held with integrity for at least a generation or two,
mm.
you know, founded on science and transparency and empiricism.
You mentioned a minute ago profitability and the potential for lower costs with healthier animals. Could you just talk a little bit more about that? Like, do you see a link between the sorts of approaches that might build nutrient density in foods and the profitability or cost base of the farm?
You familiar with sauerkraut and um, sourdough bread and
Mm,
kefir?
absolutely.
You understand the concept that when you
Yeah.
microbes pre-digest your food for you, it's more bioavailable. So imagine the cow has a couple round bales of hay that have been deeply fermented, which will support the gut flora of the cow. Imagine that the chicken or the pig doesn't have cracked and extruded grain, but sprouted and fermented grain. They don't have the phytase inhibitors. They don't have the high omega-6, omega-3 levels. If we begin to feed our animals remotely more well, their, their pounds per day will increase. Their cost of feed per day will decrease. Their vet bills will decrease. Their grading, choice, prime, etc., will increase. Um, it's simply about working more well with nature. And I mean, we know about our gut flora. I mean, why are we not doing that with animals? I mean, cracked extruded grain is not good for us. Why is it good for a chicken or a pig? It's not. It's not. It's suboptimal, but we're all taking part in that system because it's what we've been trained with. If we begin to shift how we feed our animals, I think with the opportunity for a dramatic decrease in cost of production is at our fingertips, and that will correlate directly, if we do it right, with massively improved nutritional metrics, which can be tested with meters.
So we're looking forward to seeing the results of that beef study towards the end of the year, and we'll follow that
Yep.
eagerly. Just one final question from me before we go to some of the questions from that are coming in from the audience. I just wanted to get your thoughts on how all of this relates to broader, I guess, biodiversity and ecological health in farming systems.
That's the slide we're looking at for the last 10 minutes.
Hmm.
The broader the biodiversity of plants on pasture, the healthier the beef or the milk.
Hmm.
That's the slide. It's directly correlated. Like diversity connects really well with quality with animals on pasture. So if you've got, if you're doing a annual ryegrass, that's better than corn. If you got ryegrass and clover, that's better than just ryegrass. But if you get 5 or 10 species, you're pretty much guaranteed to be having high quality meat. That's what the slide is.
Yeah. Yeah, and obviously higher plant diversity provides the foundation and the habitat for greater biodiversity of
All
above
those
and
other
below ground.
things. Yeah,
Yeah,
exactly. Yep.
absolutely. Thanks. Now we've got quite a few questions coming from the audience, so we'll see how many of these we can get through. I might just stop sharing my screen for a moment. So we've got a question that was submitted before the event. Have you experienced any pushback or opposition from agri-food businesses who might be concerned about consumers having this level of knowledge about their food?
We've done a good job being so grassroots and having such a horrible communications presence that I don't think any of those companies know who we are or what we're doing. Although we are working with a few of them who are on the cutting edge that are buying significant poundage of meat from Australia and Uruguay, and we're working actively to support them in making claims.
Mm-hmm. You might have touched on this before, but we had another question about like how far away the handheld device is. I'm not sure if you responded to that.
For animal products.
Just the scanner for food. So I think that the
So you
device
have to do
exists.
every crop needs its own testing.
Yeah, yeah,
And we've done beef so far, and we might have something for beef in the next, I would say in less than 2 years, I can say pretty confidently.
yeah.
And all animal products in less than 2 years, also possible. But for grain is next. It's $250,000 for the science, and then we have to engineer and manufacture. So it's a timeline. It's a process.
Yeah.
Our foundational commitment is that the data is open source,
Mm.
that any company can make meters, and we will do our best to say this meter is true, this meter is not.
Yeah.
But foundationally, we have to do the science first, and that requires money. And it's all open source. We're a nonprofit. It's donations.
Mm. Mm. And the advice, the device itself exists. It can be purchased. It exists. What you're flagging there is that the benchmarking doesn't
No. We
exist.
we built the device to show it's possible to build a handheld consumer priced meter that tests nutrient levels. We have not yet built a meter that's calibrated to nutrient density for any crop,
Yeah, yeah,
because you have to do the science to define it first. You
yeah.
can't build a meter to test nutrient density until you define nutrient density.
Yeah, yeah. So you could take one of these devices into a supermarket and get a readout of all the different levels of different things in a carrot, but you wouldn't be able to know whether that's good or not.
And most of what's available to you now is many tens of thousands, and we'll bring it way down in price.
Yeah,
Yeah.
yeah, yeah. There's a question here from Christopher Wilmot in the chat. How do you determine which elements and compounds you're going to monitor? And is that decision founded on micronutrient deficiency? I think the implication there is it founded on things that the human population tend to be lacking in?
Yeah, and you can go back to I think the second slide on beef we had. We're looking at about 250 different compounds in the steak. We're looking at 200 different microbes in the manure. We're doing human health trials. We're looking at the forage. We're looking at the soil. We're looking at management. And we're giving all that data to credentialed scientists to give us 1 to 100 scales on.
Is that the slide?
Yeah, exactly. So in meat, we're looking at minerals, vitamins, enzymes, fatty acids, amino acids, lipids, proteins, polyphenols, antioxidants. In stool, we're looking at hundreds of different microbes, multiple kingdoms, forage, soil, human health trials. Our thesis is if you collect the data and you give the biochemistry information to the biochemists and the microbiome data to the microbiologists and the human health trials data to the nutritionists and the forage and soil data to the agronomists, and you ask them each to take the data they can see and scale it 1 to 100. If we share that across different perspectives, we'll find patterns. That's the thesis, is there's a pattern in nature and we're working to find it. And what we've seen so far is it looks like omega-3, omega-6 is one of those patterns. But we are not done with this project and we won't be done till the end of the year.
Yeah.
But that's how we're doing it. We're not presuming to propose a answer. We're presuming to collect a bunch of data and engage knowledgeable, honorable, credentialed people in this conversation. And if people know people in Australia or wherever that want to be part of this conversation, I completely welcome their engagement.
Yeah.
This is what we're doing in the next 6 months.
Brilliant. Yeah, we'll have to get you over here to do the same sort of thing in Australia at some point. We've got another question about it was a question about the comment about microbial respiration. Just someone wanted a bit more of an explanation. As I understand, that's a measure, a way of measuring the amount of microbial activity that's going on in the soil by looking at the amount of is it carbon dioxide being released?
Yep. You take the soil and you dry it out, and then you have a certain quantum of soil and you add a certain quantum of water and you put it in a closed environment and you measure the CO2 in 12 and 24 hours.
Yeah.
It's very rudimentary, but it's the only thing we found that correlates.
It's interesting. So, and there's a related question about, someone asked, Rebecca asked, there's some of the practices you would say would lend themselves to more soil life, but I think what your data seems to show is that yes, they may in the right context, but what really
Yes.
matters is whether they are actually effective in
In
stimulating soil
context.
life.
Yeah. If you're being a proper steward, these are the powerful things to do. But if you're not being a steward, then I mean, cover crop all you want and don't till, but no water, no soil life.
Mm, mm. There are a couple of related questions from Sarah and Michael. I think Michael expressed it well, saying, is more always better? If we do improve nutrient intensity of our product, will we need to consume less?
I think it's clear that if your quality of food is higher, the consumption is less. More is not always better. Imagine you've got more inflammation markers or more, you know, stress hormones. So this is why we're engaging a suite of scientists to engage this conversation.
Yeah.
We're looking at pro-nutrients and anti-nutrients and levels and ratios and what's present in the normal Western diet and people's bodies. I mean, we don't know. We have not, no one's done this before. We're doing our best to figure it out.
Yeah. Another question from Michael, what role does epigenetics of seed or animals have on nutrient integrity? Is that something you've looked at?
A massive role. A massive role. It's completely massive. The health of the mother, grandmother, microbiome, core microbiome, is completely massive.
That's interesting because the variety doesn't seem to correlate, but the epigenetics you're finding does.
Environmental conditions determine genetic expression.
Yeah.
Environmental conditions determine genetic expression.
Hmm.
The health of the mother is completely relevant.
Yeah. Yeah. And another question here from Steve Slate. It would be interesting to look at COP. I'm not sure what that acronym is meant to refer to. COP, maybe no, Dan, versus nutrient density.
No, no.
Steve, do you want to just quickly come off mute and explain what you mean by COP? You're there? Or if you cut, yes.
Cost of production.
Cost of production. Thank you.
Yeah. My experience as a farmer is that the more well my soil is, the more well my plants are. And so there's a direct connection between decreased cost of production and increased economic viability. This is, I think, foundational, is if you're actually working with nature. How many indigenous communities have worked with nature well for how many millennia? With no wheel, with no beast of burden, with no plow. I mean, we've got data from all continents, Australia being a strong one, about how indigenous communities worked epically well with nature. I think this is, I mean, something we need to be humble about, is that if you work well with nature, it's a whole different conversation, but it's a whole different conversation. What is nature and how are we working with nature? Yeah.
Well, I think that's a great place to wrap up. There are a couple more questions that are coming in and that we haven't had a chance to get to. Apologies to those who have submitted those questions and we didn't quite get to them. But look, I want to really hugely thank Dan. We really appreciate the time you've given to be here today, quite late into the night over there in Massachusetts, and we're grateful for the amazing work that you're doing. I might add that Dan will potentially be coming to Australia for the Grounded Festival in Tasmania in
I will
December.
be there in Tasmania in December, and I'm looking at other places to be later after that.
Fantastic. That's really exciting. So that's been organised by Matthew Evans and the team at Fat Pig Farm. So keep in touch to find it with them to find out more about that. So just a couple of things before we wrap up. The session's been recorded. We'll share the recording in a follow-up email. Given that Dan's video didn't work, it might be an audio recording. We're planning to turn it into a podcast, so we'll just work with that. But something will be coming, and you're welcome to share that with others who might be interested. We'll also be sharing a copy of our impact report. And before I wrap up, I do want to very briefly note that as a non-profit, we're relying on donations. We also have some grant funding. But for those of you who do have the means, we know that not everyone does. But for those of you who do have the means, please consider supporting our organisation. Donations help to keep us doing the great work we do to support farmers to grow nutrient-rich food and restore our precious soils and ecosystems. So you can always get in touch for a chat through our info@soilsforlife.org.au email. To close the event, I'd just like to quickly hand to Michelle Gorton, who is the CEO of the MacDoc Foundation, to say a few closing words.
Thanks, Ellie. And thank you, Dan, for that amazing presentation. I feel like I could have asked you a million questions. And I think the issue of nutrient density in our foods in Australia is something that we really need to talk more about. So thank you for that. And thanks, Ellie, and congratulations to you and the Soils for Life team on this really critically important 10-year milestone. Alistair McLeod, who is the chairman and founder of the MacDoc Foundation, has supported Soils for Life for 10 years. The last 4 have been through us, and we've provided multi-year core funding to support the operation. And, you know, Alistair has been there really from the beginning of Soils for Life, and he attributes much of his own journey as a regenerative farmer, regenerative farming investor, and now philanthropist, to the work and the many important relationships with the pioneers in this space, to his work and engagement with Soils for Life. So it is really part of a really critical part of the fabric of agriculture in Australia. I'll make a few comments about why we fund organisations like Soils for Life and why I think it's increasingly important for climate and nature funders in particular to turn their mind to agriculture. I mean, this conversation's been really focused on the importance of soil health and its relationship to nutrient density. But I think more broadly, supporting farmers who prioritise soil health in the way that Soils for Life does, we're really looking to ensure the long-term health of our landscapes, and that's hugely important for Australia. 50% of our landscape is under agricultural management. So for that reason, I think nature and climate funders really need to turn their mind to the way that we produce our food and that our rural communities, derive their livelihoods. I mean, healthy soils and ecosystems play a critical role in carbon sequestration, helping to mitigate climate change. They can store huge amounts of carbon, reduce its concentration in the atmosphere, and reduce the impact on global warming. Healthy soils improve water filtration and retention, reduce the risk of erosion, and nutrient runoff. So the connections to nature and climate are real, and soils are the foundation of everything, life on Earth, as Ellie said. So it's really important for us to grow the community that supports regenerative agriculture and healthy, whole, single ingredient foods, as we've heard today. And we need organisations like Soils for Life to work with those farmers to create this groundswell of producers who are managing for strong environment and climate outcomes. So as a food and agriculture funder, we are very grateful to the work that Soils for Life and many others do to support farmers, because there's never been a more important time to do so. So thanks.
Thanks so much, Michelle. That wraps up the event. So thank you everyone for joining, and please look out for the recording and the report in your inboxes after this event, and definitely keep an eye out for Dan's next trip to Australia later this year. And thanks again to Dan.
Yep. Looking forward to it. Great to meet you all.